Hey guys, it's Mr. Rambert, and today we'll be doing matrices. And what is a matrix? A matrix is a rectangular array of numbers or letters comprising of rows or columns. Rows run horizontally while columns run vertically. The size of a matrix is determined by number of rows by number of columns. Now it's very important for us to understand that everything in matrices, almost everything in matrices, comprises of the phrase row by column. So you'll see me referring to this a lot during the video. Now for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's a matrix. Now don't get this confused and read this matrix as 123, 456, 789. Each entry is a number. So 1 is a number, 2 is a different number, 3 is a different number. And we call these entry 1, entry 2, entry 3 as we go along. Now we can see clearly that in this first example we have 3 rows and 3 columns. So this is a 3 by 3 matrix. In the second example we have 2 rows and 3 columns. So this is a 2 by 3 matrix. Now different sizes of matrices, you will just determine it by number of rows by number of columns. Next we need to learn how to add or subtract matrices. Now to do this, each matrix must be the same size. So to do this, each matrix must be the same size. For example, I cannot have a 2 by 2 matrix, let's say it's 1, 4, 2, 7, added to a 2 by 3 matrix, 6, 2, 1, 4, 7, 9. This here is not possible. And why is that? Because my first matrix has 2 rows, 2 columns, so this is a 2 by 2, plus my second matrix has 2 rows and 3 columns, and this is a 2 by 3. Both sizes must be the same thing before we can add them or subtract them. So let's do one that we can actually add or subtract. Let's have a 2 by 2 added with a 2 by 2. I'll use the same one, 1, 4, 2, 7, plus 7, 9, 3, 5. Now when we are adding matrices, just add each corresponding entry. So for example, if I look at the first entry, which is 1, and the first entry in the second matrix, which is 7, I can add both of them. So the 4 will be added to the 9, the 2 to the 3, the 7 to the 5, and so on, depending on the size of the matrix. So my first entry here will be a 1 plus 7. My second entry will be a 4 plus 9. My third entry will be a 2 plus 3. And my last entry will be a 7 plus 5. And we get 7 and 1 is 8, 9 and 4 is 13, 2 and 3 is 5, and 7 and 5 is 12. And we will get back a 2 by 2 matrix as the answer. The same concept applies to subtracting matrices. So if I have 2 matrices being subtracted, let's say 1, 6, 7, 4, take away 2 minus 11, 3, 6. Well, we subtract each corresponding entry, so I'll have the 1 subtracted from the 2. Be careful here. I'll have the 6 subtracted from the negative 11. I'll have the 7 subtracted from the 3. And I'll have the 4 subtracted from the 6. 1 minus 2 is minus 1. This becomes 6 plus 11, which is 17. 7 minus 3, which is 4. And 4 minus 6, which is minus 2. Very, very simple. Now sometimes we will have variables inside of these matrices. So if A is a matrix and the matrix A is 1, 6, 0 and minus 4, and I'm just making up, and B is the matrix 2, A, 3, 4, and the question states that if A and B are that, and they say A plus B is equal to C. Now let me put in a matrix C, where C is the matrix 6. Let me put X 2, y and Z. And we see that if A plus B is equal to C, what are the values of A, X, Y, and Z? And this here caters for every single type of question where we will have a variable in addition or subtraction of matrices. So I'll have A, which is 1, 6, 0, minus 4, plus B, which is 2, A, 3, and 4, is equal to C, which is X, 2, Y, and Z. I'll add my left hand side. So I will have a 2 by 2 added with a 2 by 2. It is possible. So my first entry, 1, 1 plus 2. My second one will be 6 plus A. My third one will be 0 plus 3. And my last one will be minus 4 plus 4. Is equal to X, 2, Y, and Z. Now if you realize, on the left hand side, I do have a 2 by 2 matrix. My first entry is 3. My second entry will be 6 plus A, that is a number. My third entry is 3, and my last entry is 0. Is equal to X, 2, Y, and Z. Now this happens every single time we have a case like this. If I have a 2 by 2 matrix is equal to a 2 by 2 matrix, we say the matrices are equal and equate corresponding components. The same thing occurs if I have a 3 by 3 matrix is equal to a 3 by 3 matrix, or a 4 by 4 is equal to a 4 by 4, and so on. So this is a 2 by 2 is equal to a 2 by 2. We need to say that matrices are equal, equate corresponding entries. So my first entry will be equal to my first entry. So I will have 3 is equal to X. I will have 6 plus A is equal to 2. Rearrange. A is equal to 2 minus 6. A is equal to minus 4. My third entry, 3 will be equal to Y. And my last entry, 0 is equal to Z. And this occurs every time I have a matrix addition or subtraction along with variables in it. Now let's move on to matrix multiplication. Now matrix multiplication is very, very important. And before we do matrix multiplication, I'd like to show you guys how to label a matrix. So we're going on to matrix multiplication. If I have a matrix, and this is it's a 2 by 2 matrix. We have 2 rows and 2 columns. So I have an entry here, an entry here, an entry here, and a entry here. Now each entry is denoted by a E, but each entry has a particular name, and the name of an entry is given by E subscript ij, where I is the row number and j is the column number. So for example, my first E, this one here, that's in my first row and my first column. So row number is 1 and column number is 1. So we read it as E11, not E11. My second entry, if I'm dealing with this one here, again, it's in my first row and in my second column. So E12. The one below, it's in my second row, first column, and the last one is my second row, second column. So let's try and label a 3 by 3 matrix using this method now. If I have a 3 by 3 matrix, and I have 3 rows, 1, 2, 3, and I have 3 columns, 1, 2, and the first column. So we just fill in the rest with E's, and we start labeling our E's. So first row, first column, first row, second column, first row, third column, second row, first column, second row, second column, second row, third column, third row, first, third row, second, third row, third. And this is important when we are multiplying matrices. Now, Just like in addition and subtraction, we had some particular condition being satisfied, and that condition was matrices had to be the same size before we were able to add or subtract them. Something similar happens for matrix multiplication, and I'll just put it very, very quickly for you all for the video. So if I have two matrices, A and B, and A is some, I'll put it on the underneath, is some m by n matrix. So it could be a 2 by 2, it could be a 2 by 4, it could be a 3 by 1, whatever the case might be. M and n are any number multiplied by another matrix, and let's say this matrix has a size P multiplied by Q, where P and Q are any two numbers. The only time we are allowed to multiply is if n is equal to P. So I put it, if n is equal to P, then matrix multiplication is possible. Another thing happens with the size of a matrix. The size of the answer is m multiplied by q. So my answer will now be a m by q matrix. So let's put numbers to these things now. So for example, if I have, let's say, 4, 3, 2, 1 multiplied by 6, 9, 7, 3, and this is a very basic example. We have matrix multiplication. I want to check. My first matrix is a 2 by 2 matrix. My second matrix is also a 2 by 2 matrix. N in this case is 2. P is 2. N is equal to P. So it is possible for me to multiply these two matrices. So we're good to go on that aspect. I want to check the size of my answer. The size of my answer will always be m by q. M is 2, q is 2, so this will be a 2 by 2 matrix. Now, given that we established that this is a 2 by 2 matrix, every single time we will label our matrix now. Entry 1, 1, first row, second column, second row, first column, second row, second column. Very, very simple, very straightforward. Because I label these matrices now, I need to figure out what E11 is, what E12 is, E21 and E22. So let's try and figure out what they are. E11. Now this is the trick in matrix multiplication that's going to make it so simple for you guys. E11. Each of these numbers represents something. Remember in the beginning, I told you all, everything in matrices, or most thing in matrices, is row by column. So think of this as row and think of this as column. My first entry is my first matrix. My second entry is my second matrix. So the row comes from the first matrix and the column comes from the second matrix. So I'm going to write that out now. The row in my first matrix is the first row because it's 1. So the first row is 4, 3. The column comes from my second matrix and that's the first column, 6, 7. When multiplying matrices like this, it's always first by first plus second by second. So it's my first by first plus my second by second. So it's 4 multiplied by 6 plus 3 multiplied by 7. This is 24 plus 21, which is 45. Let's see what happens to E12. Again, this E12, the 1 represents the first matrix and it represents the row. So that'll be 4, 3. The 2 represents the column in the second matrix. 9, 3. Again, first by first, second by second. 4 by 3 plus, 4 by 9 plus 3 by 3. 9 4s are 36 plus 3 3s are 9. Here we get again 45. E21. Again, the 2 represents the row in my first matrix. So So the row in my first matrix is 2, 1. And the 1 represents the column in my second matrix. That'll be 6, 7. Again, second row, first column, first matrix, second matrix. First by first, 2 by 6. Second by second, 1 by 7. 6 2s are 12, plus 7, we get 19. And lastly, E2, 2, second row, second column. First matrix, second matrix. Second row, second column, go ahead and multiply them. So we get 2 multiplied by 9 plus 1 multiplied by 3. 9 2s are 18, plus 1 3 is 3. 18 and 3 is 21. So the answer, if I have 4 3 2 1 multiplied by 6 9 7 3, the answer is E11, E12, E21, E22. Very simple. Let's do another example. This time let's shake up the sizes of the matrices. If A is equal to another 2 by 2 matrix, 1 6 0 minus 4. If B is now, let me say B is a 3 by 2 matrix, so 3 rows and 2 columns. So 1 6 9 4 7 3 2 1, or 3 by 2, okay, 2 columns, good. And C is now a 2 by 3, 2 rows and 3 columns. 7 3 minus 1 4 6 2. Let me see what is possible. AB, it could be 1 6 0 minus 4 multiplied by B, which is 1 6 9 4 7 3. Let's list the sizes. A is a 2 by 2. B is a 3 rows and 2 columns. You realize that M is not equal to P, so this here is not possible. Let's try AC now. AC again will be 1 6 0 minus 4 multiplied by C, which is 7 4 3 6 minus 1 2. This here is a 2 by 2. This here is a 2 rows and 3 columns. N is equal to P, so it is able to multiply. The answer will now be a 2 by 3 matrix. So this will have 2 rows and 3 columns, 1 2 and 3. Fill out the rest and label them. First row, first column, first row, second column, first row, third column, second row, first, second row, second, second row, third. So let's calculate each one of these matrices now. Each one of these entries, sorry. E11, first row, first column, first matrix, second matrix. So the first row is 1 6. The first column is 7 4. Row by row, first by first, second by second, 1 by 7 plus 6 by 4. 7 plus 24, and we get 31. Next, E12. First row, second column, 3 6. First by first plus second by second. 3 plus 36, 39. E13. Again, first row, and this time we're dealing with the third column, minus 1 2. First by first, 1 by minus 1 plus the second by second, 6 by 2. Minus 1 plus 12, we get 11. E21, and you can pause the video and see if you can work out the rest of these entries by yourself. So E21 will be the second row, 0 minus 4. First column, 7, 4. First by first, 0 by 7, plus second by second, minus 4 by minus 4. Minus 4 by positive 4. 0 plus negative 16, and we get negative 16. E2, 2 will be the second row, 0 minus 4. Second column, which is 3, 6. First by first, plus second by second. This will be 0 plus negative 24, and we get negative 24. And lastly, E2, 3. Second row, 0 minus 4. Third column, minus 1, 2. First by first, plus second by second, minus 4 by 2. We get 0 plus negative 8, and we get negative 8. So my solution will be E11, E12, E13, E21, E22, E23. Simple as that.